Alright, so let's start by looking at some of the homework problems here. First of all, number 41. The nice thing about 41 is that it is already in terms of one trig function, secant. So we have this secant squared x minus secant equals 2. Now this is a quadratic form because we have a secant squared. So I'm going to go ahead and get it equal to 0 by subtracting the 2 first of all. Okay? And then we have to think, okay, how do we solve a quadratic equation? We can do the quadratic formula or we can factor. Okay? I would recommend factoring in this case because it's a relatively simple one here. So we're going to have secant x and secant x. I know the signs have to be different so that I can get a negative on my last term there. And the only way to factor 2 is 1 and 2. So I just need to do it in a way that makes sure I get a minus 1 in the middle. So I'm going to get a minus 2 and a plus 1 to get my minus secant in the middle. Alright? So now I know what secant equals. Secant x is a negative 1, or it's a positive 2. Okay. So what would we do from here?
I'm sorry for interrupting, but are you going to get the quiz back?
Yeah, I'll give those back to you here a little later.
Today?
Yeah.
Do you plug it in? Oh wait, isn't it 2 because it can't be a negative?
Well, secant can be negative. Yeah, I would change this into cosine. Okay. Now, if you guys have the n spire does have an inverse secant button on it, but the 83s and 84s don't. And honestly, we don't need it anyways. If we make this cosine, cosine is simply the reciprocal of secant, so the reciprocal of negative 1 is negative 1, and the reciprocal of 2 is a half.
So it's pi over 6 and 50 over 2.
So it is, let's see, cosine is negative 1 at, you're thinking sine, yeah, it'd be at pi, okay, and cosine is a half,
Pi over 3.
pi over 3,
Or 5 pi.
or 5 pi over 3. Okay, so we got 3 answers here.
Do we have
What?
to do the...
Oh,
How do I do
you can just kill it, it's fine.
Brett, keep it.
No, don't kill it. It's mean.
Kill it.
Brett, raise it as your
Throw it
own.
out the window.
It's not where it belongs, so.
It's its own fault.
Hey,
Throw it out
Brett.
the window.
Eat it.
Brett,
All
it's
right.
your problem now. Raise it.
Anyways,
Wait, do we have to put the thing in
Eat
the
it.
equation? The one that's like plus 2 pi and yes.
Here's the thing, if we have these answers, these are the answers in the interval from 0 to 2 pi, okay? When your book just says to solve, or find the solutions, in this case it said find the solutions from 0 to 2 pi, so we don't need to do that here. If all it said was solve, they're wanting general solutions, so yes, you would on all of these put a plus 2 pi n. Okay? We aren't doing it here because we have the interval that they asked us to solve it on. Okay? Oops. There we go. Okay. So that would be our solution. Those 3 angles are the solution. Now, again, that was 41. Okay, 43. Here, I'll do 43 in red. Okay. 43 was a little bit of a challenge because we had 2 sine x plus cosecant x. Now, cosecant and sine are related because cosecant is
1 over
1 over sine. Good. So now the question is, how do we actually solve an equation like this? Okay, we could get a common denominator. Kind of a similar thing to that would be just, have another idea?
Sine over x on both sides.
Yeah, just multiply everything by sine on both sides of the equation, okay? So if we do times sine of x times sine of x times sine of x, basically it's the same thing that you would have done. It's just we're cutting out a step in the middle. You would have had something over sine of x, and then you would have had to get rid of the denominator. So here we have 0 times sine of x is 0, sine over sine is 1, and here we have a 2 sine squared x.
And then you say,
And that's undefined, right?
could you?
We could put in a 1 minus cosine squared for sine squared if we
Yeah.
wanted. That wouldn't necessarily help us solve it any faster, but it would be possible. It would work. Yes?
Keen observation.
Does this change the degree of it and like produce an extraneous solution or no?
This does change the degree. We're multiplying by a sign, so it is possible that we could end up with extraneous roots here. Yeah. So we will need to check our answer at the end. Now, one thing with this one, if I subtract both 1 and then divide by 2, I now have sine squared x equals a negative 1/2.
And
So what's up?
is that undefined?
Well, let's think about this. If I square root it, what do I get?
Plus or minus?
Negative. No.
Well, it's a square root of a negative, right?
Yeah.
Minus.
Square root.
So it'd actually be I root 2 over 2.
Yeah.
Oh,
Plus or minus I root 2 over 2, which obviously
That's just.
is not a real number.
What?
So what?
Your
No
answer.
real
There must not be any real solutions. Okay?
What?
Now we can confirm that. We could confirm that. Or actually test that theory using our graphing calculator. Okay? Let's bring that up here. There we go. And this is kind of getting to something we'll look at later, and that is solving an equation using the calculator. But you'll notice I'm gonna go to my y equals, and I'm gonna put in 2 sine x plus, and I need to do the cosecant, so I'm gonna do 1 over sine x. There might be a cosecant in there somewhere, but why bother trying to find it? if we can just do 1 over sine. All right, so now before I just hit graph, I'm gonna check zoom. All right, and I'll leave my x alone, but I'll leave my y alone. But the interval we wanted for x was from 0 to 2 pi, and you can actually just punch in 2 pi right here. Okay, and I'll leave y min. Maybe I'll do my y min down to a -5. Just to zoom in a little bit and up to 5. All right, so now we hit graph. That's kind of a strange looking graph.
Uh-oh.
All right,
It's kind of like
so if it equaled 0, what would happen on our graph?
It would touch the x-axis.
there's
It would touch the x-axis. So guess what? We just confirmed with the graph that this is a valid solution. Okay? There is no solution. All right? There's no solution here. For this equation. Right?
Is it above and below because of the 1 over sine?
Yeah, remember the cosecant function? We looked at the graph just briefly. It had it had asymptotes everywhere where sine was 0. So at pi over 2 and 3 pi over 2 and so on, it had those asymptotes, and that just had the little, looked like parabolas,
It looks
up here
like,
and then down here and then up here and then down here and so on.
Like the graph of is that secant?
Well, secant, cosecant have very similar graphs,
Yeah.
but that's because they're derived from sine and cosine, which have very similar graphs. Okay, so it's possible to end up with something like this. Okay. All right, now 46 and 47 are very, very similar types of problems. Okay, so as such, I'm not going to do both. I'll do 46 since it's even and you can't find it online. 47, if you really want to see it after we've done this, you can go online and look for the solution. Yeah, Gianna? So, I'll do this one in purple here. Our first thing we want to do is get everything in terms of one trig function. And how would we go about doing that?
Sine squared is 1 minus cosine squared x.
That's right. Sine squared is 1 minus cosine squared. So there we go. We plug that in and now everything's in terms of cosines.
So if you like divide by a negative or like multiply by a negative, does it change the solution at all?
No.
No?
No. As long as you're fair to both sides of the equation. In fact, in this one, I would go ahead and do that so that I'd have a positive cosine squared because it's easier to factor. Okay, so that's positive cosine squared minus cosine, and then a 1 and 1 is 2, so times the -1 would be a minus 2. And of course 0 times -1 would be 0. So now this one factors cosine x minus 2 times cosine x plus 1. Okay. So that leaves us with cosine equaling 2 or -1, right? So now what?
It equals pi.
Okay. Cosine is -1 at pi. Alright, where is cosine 2?
But it's not
Undefined.
the 0 to 2 pi, is
It's
it?
some imaginary axis.
What?
Like, 2 is not in the 0 to 2 pi thing, so.
Well, that's what the angle could be. This is what your function can equal. That's in your range. The 0 to 2 pi is our domain for x. 2 is 2 in the range though?
No,
Why not?
the negative 1 to 1 is the range for cosine.
Exactly, okay? Negative 1 to 1 is our range for cosine, so we're not going to ever get an angle that'll give us a cosine equal to 2. Alright, so we don't get any solutions from the 2, but we do get a solution from negative 1. Alright? Alright, any other questions you guys have? Okay. Now, want to look at a couple of other equations or types of equations that we can solve, but let's again review our basic strategy or general strategy here for solving. Remember, we want to try to get the equation in terms of one trig function. We're going to get that trig function. We're going to solve it based on whether it's a linear or quadratic. You're either trying to get the trig function by itself or you're setting it equal to 0. Okay, one or the other. Then, once you do that, you're using inverse trig functions to find the actual answers. Now, we did one kind of similar to this one here already as we were going over the homework. But I'll point this out. One of the things that we could do to get our equation in terms of a trig function occurred when, if you look, we have cosecant minus 3 equals cotangent. Right? And as it is, there's really not a good way, I'll show you the original here, there's really not a good way to get that in terms of one trig function. Alright? Now, one possibility is cosecant's 1 over sine, and cotangent is cosine over sine, so you might try multiplying by sine, but then you're going to have a mixture of sines with cosines, because this 3 doesn't have a sign to cancel out. Alright, so that won't even help us here. So what we're looking at are situations where you can't get it in terms of one trig function very easily, and this is a key, the two trig functions involved are both part of the same Pythagorean identity that you see over here. 1 plus cotangent squared equals cosecant squared. Now, if it's not, then we're going to have to use technology to solve, okay? Or maybe try some other stuff, but usually we'll just use technology to help us solve that equation. But what we have here is a situation where we're going to kind of set it up so that we can get to this point by squaring both sides of the equation. Alright, so that's what I did here, and we saw that a cotangent squared is cosecant squared minus 1. So once I square both sides of the equation, notice everything's in terms of cosecant. Alright? Now this is what we ended up with on Friday. We did an example like this, not this example. But we also looked at one in your homework that was like this. So I'll let you look a little more closely at this one if you'd like on the notes. But again, we've done a couple similar to this. The only thing that was a little different on this one is the interval. And I did this intentionally. I went from negative pi to pi. Okay? This did not give us a solution that was on our unit circle, so we have to use our calculator. Do the inverse sine of 3/5, and your calculator is going to give you 0.64. Alright? And of course that's in radians. Now our interval is negative pi to pi, and you'll notice I drew it here, rotating backwards to negative pi and forwards to positive pi. So you'll see we still have the second and fourth quadrants. So we have the first and second quadrants in our interval, but we would not give an answer like 4 radians, because 4 would be rotating all the way over to here. What we would do is figure out what that negative angle is inside the interval. Okay? This one, however, we don't even have to do that with. Okay? We take the inverse sine of 3/5 and we get 0.64 as our reference angle. Okay? That's our first quadrant angle. Then we recognize that, hey, sine is positive in the second quadrant as well. So I use that same 0.64 reference angle in my second quadrant, and instead of going all the way to pi, I'm that far short of pi, so 3.14 minus 0.64 is approximately 2.5 radians. Okay, so those would be our two solutions there. And we actually don't need to worry about extraneous roots because our squared terms ended up canceling out. So that was kind of nice. So, on to the new things, okay? The new stuff for today. What I want to look at today are situations where the angle we're taking a trig function of is actually an expression. So in this case, we're taking 3 times the tangent of x over 2 plus 3 equals 0. And 2 times the cosine of 3t minus 1 equals 0. And as you look at that, what's your initial thought? How might we handle this? Amanda?
Move the 3 over to the other side and then divide by 3.
Okay, so we would end up with tangent of x over 2. We'd subtract the 3 and divide by 3, so you'd get negative 1, right? You guys agree with that?
I do agree.
That seem reasonable?
Yes.
It does.
Yeah, it seems reasonable. We didn't do anything against the rules here, so.
It's gonna be wrong.
Okay. So what would we do then?
Multiply by 2.
No.
Multiply by 2?
No.
But you can, well, you can divide it, can use the tangent of the other tangent too. I think you can split it up like that.
That's not a bad idea, but we can't split it up like that. We can't just multiply everything by 2. We can't split it up to be tangent of x over tangent of 2.
Oh, but the first part
We
was right.
can-
You got it like that?
Yeah,
Oh, okay.
yeah, you were right.
We can solve
You could say like.
we're gonna solve x over 2
Okay, so,
by using inverse tangent.
alright, use inverse tangent at this point. Where do we have tangent equal to a negative 1?
Somewhere.
The second fourth
I think it's
quadrant.
3 pi over 4.
Second and
3
fourth.
pi over 4.
Second and fourth.
Second and fourth, so yeah, 3 pi over 4.
And
And
7
pi over 4.
There we go, good. Now, is that x?
No.
No,
that's
what
x
is
over
that?
2.
That's x over 2.
Oh no.
Oh no. Well, how do you solve that? If you have x divided by
You just use
2.
one?
Multiply.
Multiply everything by 2.
Yeah. That's
Or
not
divide
hard.
Everything by 1 half.
That's not bad at all.
Okay.
Is the or part of the
Yay.
equation?
You can divide
Well,
everything by
those are
1
your 2 possibilities.
Okay.
So rather than writing 2 separate
Which is
equations, I just put or.
Gotcha.
Alright, so that gives us now x equal to 3 pi over 2 or 7 pi over 2. Okay?
Yay.
Now, what you'll notice at this point, and this is where you have to be a little bit careful, if we were finding it on the interval from 0 to 2 pi, okay, check this out. 7 divided by 2 is 3.5, so that's outside of our interval.
You can
right?
find the coterminal angles, right?
So yeah, if we subtracted 2 pi from this, what would we get?
3 pi.
3 pi over 2.
Subtracting 2 pi from that.
So
If
it's
we
the
subtract
same.
2 pi from that, we're below 0, right?
Yeah.
So actually the only solution within our interval is this. Okay? That's one thing you do have to be careful with when you're working on these types of problems, is that it's possible to get values that are outside, that originally were inside our interval, but then once we finish solving for x, then fall outside the interval. So you just take a look at that and make sure you've got it in there. Yes?
So the interval is just for x, not for the whole inside the parentheses.
Yeah, we're trying to find x that's in that interval. Okay? Okay? Why don't you try the second one? 2 cosine of 3t minus 1 equals 0. I'll pass these back while you're working on it. I have the makeup tests in here as well.
Would you still do the inverse thing?
Yeah.
No, it's okay. We still have to stay within 0 and 2 pi.
Yeah, let's go ahead and stay inside 0 to 2 pi. How's it coming? Alright, so what does cosine of 3t equal? Well, cosine of 3t would be a half, right? And then 3t would equal, I think I heard it, but
Pi over 3 and 5 pi over 3.
pi over 3 or 5 pi over 3. Okay? Well, where does cosine equal 1/2? It doesn't matter what we're taking the cosine of, it's just where does cosine equal a half at those two values?
If it's like 1000 t, it doesn't really matter.
Doesn't matter. Doesn't matter. it only matters once we get to this step, then we're going to divide everything by 3. Sorry, that's sloppy. Okay? So now that gives us t equal to pi over 9 or 5 pi over 9. Okay? Yes?
I don't understand how you know if it's in the 0 to 2 pi range, like for the other numbers.
Well, just look at the fraction. Look at the fraction and is it bigger or smaller than 2? You know, our answers have to be positive if it's 0 to 2 pi, and it's got to have less than 2. So 7 over 2 is 3.5, so we knew it was outside. That's only 1.5. These are obviously less than 1.
Yeah.
So, and if I tried, and the other thing is, okay, could there be another one since that's so small? Well, not if I'm going 0 to 2 pi. Here's the thing, if we were going, say, 0 to 3 pi, then we might have another answer in that range, okay? So that's why you just look at the range that you want for your solution, and just give all the ones in there, so. Okay, are there any questions about that one? Okay. The last little bit, and we'll pick up with this tomorrow, but when we have to use our calculator, there are frankly some equations that we just can't solve by hand, alright? But here we have an equation, but since we have a graphing calculator, we're able to solve it by looking at the graph. And I'll just sketch this one so you can see it. The line y equals x would represent this side. Alright, so here's that line y equals x. And if I look at that in relation to my sine curve, 2 sine of x, well, let's make that red, okay, it's going to go up to 2, and this is not going to be drawn to scale, but we want to go from negative pi to positive pi. That'll be pi over 2. This will be a negative pi over 2. Where does sine start at?
0.
0. It goes up to its max
2.
by pi over 2, which in this case is 2 because our amplitude's 2. And then it's back down to the min at pi. So here's part of it. And then negative 2 is down here. So it's going to be down at the min value, negative 2 at negative pi over 2. And then it's going to be back up to 0 by the time we get to negative pi. Alright, so here's one where the interval is a little different than what we're necessarily used to looking at. Okay? How many solutions are there going to be for this equation now? 3.
Oh, in the interval. Sorry.
In this interval. Okay? We're going to have a solution here, a solution here, and we actually know one of the solutions already. 0. Okay? So we know x equals 0 is a solution. It's just a matter of finding these other two values. Okay? How would we use the calculator to do that?
Find an intersection.
Graph them both, find the intersection. Okay? By the way, you can help yourself using your calculator if you'll set your window.
You have no battery, by the way.
Yeah, I think I'll make it the rest of the period. Okay. If I set my window, oh, it didn't like that. I'm going to make my x range for my window go from negative pi to pi. All right, so here's the graph. We got y equals x in one graph, and we have y equals 2 sine of x. We are in radians by default here. I'm going to set my window for the x range to go from negative pi to positive pi. And notice it converts it there for me. I'm also going to make, since I'm dealing with 2 sine, I know I'm not going to go below negative 2, so I'll set my window at negative 3 just for some extra space, and I'll have it go up to positive 3. And now when I hit graph, okay, looks an awful lot like what we just sketched, right? So now we can use that calc function. Second, calculate, and we're going to do intersection, number 5. And it asks us for the first curve. I'm going to scroll over a little bit here. So the first curve is my line y equals x, so I hit enter. My second curve is this y equals 2 sine of x, so I hit enter again. And then it's asking for a guess, so I'm going to scroll over here close to the intersection. And there's one of the solutions at 1.895. Okay? So now I know 1.895 is a solution. And by the way, are both of these symmetrical?
Yes. No.
So what? Yeah.
Negative 1.95.
So what's the other solution going to be? Yeah. Negative
How
1.
could it have to be radians ranges?
Yes, it does.
Always. Alright,
Okay. Alrighty. Have a great day.